So 1.5 is about limits. So this is kind of your first taste of new calculus sort of stuff, okay? So limits are something, it's just a little odd thinking, but once you wrap your head around what the concept is really trying to say, I think you'll like them. I like limits. They're not bad, okay? So let's take a look at this problem. Now, this is a notational thing. So you're going to put LIM underneath it, what number you're heading towards. So that just means I am taking the limit of my function as x approaches 2. So that's how you read that. And you should, I know, some of you don't write cursive very often, but it's helpful to write LIM in cursive. It's helpful. And then we're going to have whatever the function is. They've written the function out. You can just put an F there too. And so this says, on my function F, what value am I approaching as x goes to 2? So it's saying, as x approaches 2, what height am I at? And it's really not what height am I at, it's what height am I approaching. So if we look on the left side of 2, like 1, 1.5, 1.8, 1.9, you can see that we're getting super, super close to 4. And if I go from the right, 3, 2.5, 2.2, all the way up to 2.001, I'm also going to a height of 4. A limit doesn't guarantee that I am hitting a height of 4. It is saying, what height are you heading toward? It doesn't necessarily guarantee that I land there, but the answer would be I'm heading to a height of 4. What I mean by that is technically I could have an open circle at that spot, and the answer would still be 4. It is saying, what height are you heading toward? Not what height am I landing at. See the difference? The height I'm landing at is f of 4. That's not what a limit is saying. A limit is saying, if you could stand there, where are you heading? Okay? It doesn't guarantee that I'm landing there. Okay? That is a distinction because as we head, we're going to talk about something called continuity. We talked a little bit about last year where, hey, it's continuous if you don't have to lift your pencil. And continuity occurs when the limits and the function values are going to be a match. Okay, so now let's look at some different ways where the limit as we approach some value A is L, but they look different. Okay, so let me write that a little bigger for you. So we're going to limit as x approaches A of f of x is at some height L. So let's look at the first case here. It's a smooth, wonderful curve. As I go to an x value of A, I am heading to a height of L. Great. But let's look at our second case. As I am heading to an x value of A, I am heading to a height of L. Do I land there? Nope. Do I care? Nope. The limit is still L. I don't care that point there. That is not what a limit is asking. The limit is saying, as I get super close, where are you heading? Where are you heading, not where you land, okay? That's why the next one, even though it has an open circle and no value, the limit is still L. So all three of those have the same limit of L, but different circumstances happening when x is equal to A. And the point is, it doesn't matter, okay? So let's take a look at this. What does it mean if the limit as x approaches x, the limit as x approaches 1 of f of x is equal to 3? That means as x approaches 1, y approaches 3. As x approaches 1, y approaches 3. That's what that means. As x heads toward 1, the y value heads toward 3. Okay. Now, new notation that I want to talk about. So if we could write what this means. It is not a power. What this means is we are approaching an x value of a from the left. This one means we are approaching an x value of a from the right. Okay? So in B, it says we are approaching an x value of 1 from the left. We are hitting a height of 4. We are approaching an x value of 1 from the right. We are hitting a height of 6. Does the limit as x approaches 1 exist? So I'm going to draw a very rudimentary picture. Don't expect it to be anything fancy. Okay. So I can kind of have a visual for you of what's happening. From the left, we are headed toward a height of 4. From the right, we are heading to a height of 6. What is the limit as we approach 1 from the left and right simultaneously? I don't know. So the answer is no. Those two sideways limits, they're called sideways limits or side limits. Those two limits must match for the limit at that value to exist. Because what do we pick? Is it 4? Is it 6? I don't know. They have to match because the limit is saying, what are you approaching from both sides simultaneously? They have to match. If they don't match, the limit doesn't exist. Okay. You might have, there's a movie where they say the limit does not exist. Well, that's one of the types that wouldn't exist. So you could say that the limit as x approaches 1 of f of x, you can either put does not exist like DNE, or you can put the null set. Either of those two things are acceptable to me. I don't care, whichever one you want to write. Okay. But if both sides are different, we can't pick one as the official answer. We can specify, oh, the left is 4 and the right is 6, but they don't match up, so it's a no for the actual answer. Does that make sense? Kind of, maybe a little bit. Okay, well, we're good with those. Okay. So that's the notation that's on this page. So we have the left-sided limit. We're approaching a from the left. What's the height? The right side limit. The function's limit only exists if and only if the left and right match. What does if and only if notation mean? In mathematics, if you take any upper level mathematics past Calc 1, you can do IFF, means if and only if. It means it goes both ways. So you can read it both ways. You can say, if the limit exists and is equal to L, then the left side and the right side are both L. Or you can go backwards. If the left side's L, and the right side's L, then the limit is L. That's what if and only if means. They are reliant upon each other. They both have to work both ways all the time. For the limit to exist, the left and right side have to match. If the left and right side match, the limit exists. Okay, so that's what that notation for one-sided limit, left-hand limit, right-hand limit, that's what that notation is telling us, that definitions are completely reliant upon another. Now, there are some functions that might only have a left-handed limit. Let's think of our square root function. Starts at 0, 0 and swishes over. Well, it has a right side limit at 0, but there's nothing on the left side of that function at 0, so it doesn't have a left side. So some functions do have a spot where a left side exists, but a right side doesn't, or vice versa. One famous function is called the Heaviside function. It's an engineering function. It's basically on and off, ones and zeros. So anything that is less than 0, we say is the off position. And anything that's greater than or equals 0, that's the on position. And so it looks kind of like that. So this is one where the left side, as we approach 0, is 0. Right here, I'm heading to 0. But the right side, I'm heading to 1. So that tells us that for the Heaviside function, the limit as, well, they use t's. Let's go with x's because I used x's up there. The limit as x approaches 0 of h of x does not exist. Because you can't pick. Do I pick 0? Do I pick 1? Is it on? Is it off? As we approach it from either way. Okay, so that's a perfect example that has a spot. Now, if I'm approaching something way over here in the positives, it's always the limit is 1. So over here, the limit's 1. Over here, the limit's 0. No matter what I pick, the limit does exist. It's only one spot where there's a jump in the function. Okay, so let's look at our an example here where we have a function that they've asked us a variety of questions. And so I like these because it's just this kind of f of x on the page that you have to use. So let's look at A. So we are approaching 0. And so an x value 0, these kind of are hard to read. So I would suggest on your paper making the lines, the xy axis a little more noticeable. Okay, make the x and y axis just a little more noticeable so you can kind of see what those values are. Okay, so let's go to 0. From the left and the right, it's defined nicely. It's a continuous spot in the function. What height are we heading toward? 3. So this one's 3. Now, B is saying it has a specification that we are coming in from the left. So it's a left side limit. So here's 3. If we come in from the left, we are heading to a height of 4. Now, I don't care that we don't land there. Doesn't matter. That's not what a limit's saying. Where are you heading? Well, if I'm walking and I'm at 2.9, I'm heading to a height of 4. Don't care if we get there. That's where we were heading. But remember, this one is a right-handed side. So we're coming in from the right. We're walking from the right. What height are we heading there? 2. Does the limit exist at 3? Does the limit exist at 3? Nope, those don't match. So that doesn't exist or null set. But E is totally different. E says, what is the value of the function when x is 3? It's got a value. There's a dot there, a closed-in dot at 3. So be careful what they're saying and the notation of what's written. Limits are not hard, as you can see. That wasn't very, it's just knowing that notation and then practicing that notation. Do we have any questions about example 2? Okay, let's keep going. Let's do example 3. It's a weird one. Now I'm gonna do, not only I'm gonna make the X and Y axis a little more noticeable. Because my brain will just mess it all up, okay? But I'm also going to just draw on the function a little bit because this, it's just a little hard to visualize. So let's just make the function a little more noticeable. Especially this part. I don't know how good I'm going to match it, but I'll do my best. I don't even know. It's one of those weird Desmos things you're putting in there. Okay, so let's assume that's what it looks like. Okay. Okay. So the first thing says we're going to state the value of each quantity if it exists. If it does not exist, it says explain why. I'll verbally explain, right? You don't have to write it unless that helps you. Feel free to write it. Okay. So what does the notation mean in A? What does that notation mean in A? Going to -2 from the left. Okay, so let's go to our graph. We are going to -2 from the left. What height are we at? Heading toward? -1. Okay. B, what's that notation mean? Yes, from the right, right? Okay, so that's up here. What height are we heading toward this time? +1. Okay. So then C says, what height are we heading toward at -2? Well, do those side limits match? No, so that is, it doesn't exist. But let's look what they said for D. D says, but what is filled in? What height would you be standing on, Alex? What did you say? Yeah, it's this point right here. Perfect, perfect, perfect. So we actually land at a height of 1. Now we're going to do the same thing for an X value of 2. An X value of 2. So all of these right here are related to 2. E, F, G, and H. So E says as X is 2, we are heading in from the left. So we're going there. That's a height of 1. But if we go from the right, we're heading to 2. So the limit doesn't exist because those don't match, right? But what is filled in when our X value is 2? 2. Does everybody see how that worked? Okay, so from the left, I'm heading to a height of 1. From the right, I'm heading to a height of 2. They don't match, so the limit doesn't exist, but we are filled in at the point 2, 2. Okay, are you seeing how this notation works and how you can grab the information from a picture? Okay, it's practice, okay? And then finally, we're dealing with 4. An X value of 4 is heading to a height of 2 from the left. That's this one. Oh no, that's from the right. I'm sorry. From the right, even though it's wiggly, we're still heading toward that same height of 2. as x is 4 from the left, we're still heading to that height is 2. What I didn't like, we're going to add a little extra one. So what is the limit as x approaches 4 for the g function? Yeah, it's 2. What is g of 4? Do we have a close-in dot? So that's the one that doesn't exist. So I think that's a good little extra piece of information for our brains. What is g of 0? There's nothing there. Doesn't exist. But what is the height as we approach 0 from both sides? 0. So this is 0. Okay? So limits, again, it's about what are they asking you and knowing that notation. If you know that notation, you will do much better than, make sure you know the notation that's going on. Make sure you know the notation that is happening. Okay? So let's stop there. That's a good place to stop. Hold on to these notes. You don't have to do anything with them. We will continue this tomorrow.